One of the most important applications is nanoscale sensors. When things are getting smaller, they create great surface. They can also increase the sensitivity of a sensor device. This is a device using fluorescent displaying different algo or other tasks. So, nanomaterials do demonstrate a powerful application for the human future. However, lots of risks are still unknown. On the positive side, nanotechnology is a revolutionary scientific and engineering concept that will have a large impact on our life. Just like what we have mentioned previously, nanomaterials have broad applications, including electronic, chemical, medical, pharmaceutical, and environmental products. Natural and modified natural nanomaterials would be good reference points for comparing the functionality, cost, and potential ecological implications of synthetic nanomaterials. While the environmental impact and health effects of synthetic nanomaterials are essentially unknown, and their use is a concern, natural nanomaterials have been part of human existence since antiquity. Many of these nanoparticles do not pose much risk either to the physical environment or to human health. So, 1. Broad applications, and 2. Natural nanomaterials do not entail much risk. Here is an example from a preliminary study at Rice University on the material of silicon dioxide, SiO2. The horizontal axis shows three materials, PBS, nanoquartz, and mu-UCl at low concentration of 1 mg per kilogram and high concentration of 5 mg per kilogram. In addition, the data were collected after 24 hours, 1 week, 1 month, and 3 months. We can only look at the data of 24 hours at this moment. You will remember that I said PBS is a buffer solution commonly used in biological research. We can just treat it like pure liquid solution without nanomaterials. Then the second material, nanoquartz, is an artificial nanomaterial of silicon dioxide. Nanoquartz is manufactured by human beings. The other material, mu-UCl, is fine-ground silicon dioxide. Mu-UCl is a natural nanomaterial. Please focus on the low concentration of 1 mg per kilogram and high concentration of 5 mg per kilogram. You will notice that its higher rate of the immune system response at high concentration of 5 mg per kilogram. It implies that it's probably more toxic to the body. So, the higher concentration, the higher level of inflammation. Moreover, mu-UCl, a natural nanomaterial, is more toxic than nanoquartz, an artificial nanomaterial of silicon dioxide. So, the natural one is more inflammable than the artificial one. This study proved that nano silicon dioxide is less inflammatory than mu-UCl, and artificial nanomaterial is less toxic to our immune system than the natural nanomaterial is. So, there is a bright side to this. However, on the other hand, there are many unanswered questions. What are the impacts? What are the impacts of the products with nanomaterials? When nanomaterials are applied, are there any impacts at the use stage, like drivers driving a car? When nanomaterials are disposed, are there any impacts at the disposal stage, like electronic equipment? Or, when nanomaterials are extracted, are there any impacts at the extraction stage, like some of our mining endeavors? Life cycle. How long is the life cycle of the nanomaterials that affects people? This chart demonstrates the exposure to nanoparticles and related hazards. People can uptake nanoparticle by nose or skin. Furthermore, after the transportation from nose or skin to the blood, the nanoparticles could spread out to the whole body, including brain, bone marrow, spleen, and so on. Which side do we take? Most of the initial reports in the media have been positive. However, we should not forget that, given the nature of nanoparticles, not all materials will be denied. So, where does this leave us? Well, we need to be aware that 1. Risks of nanotechnology are still debated among experts. 2. Right now, regulation is not in place for lack of standardization. 3. People are afraid to openly discuss risk and failure. 4. Interests of companies and research should play an important role to explore the unknown areas. Finally, that brings us to the last part, homework for this section. Please look for the following example and figure out how nanomaterials are applied in the electronics. The fields include transistors and diodes, field emitter for flat panel displays, cellular phone signal amplifier, ion storage for batteries, material strengthener. This is the recent review article recommended for those who would like to come to a better understanding of it. Well, that's all from me today, and this is the end of the section, Nanomaterials and the Risks. Hope you have learned something useful in this section. See you in the next video. Goodbye.